Alright people, let's do some Unit 1 review, because we got a celebration of knowledge coming. First off, let's take a look at our standards. We've got 4AB. This is basically, talking about random molecular motion and, all the variables. So that's pressure, volume, temperature, just talking about like what causes pressure, things like that. Very explanations. So writing explanations. And then 4C, this is all gas laws, calculations, Boyle's, Charles, Gay-Lussac's, I think I spelled that wrong, combined gas law. 4D is all about STP, you should rock that one. 4EF is all about temperature scales, converting, and also absolute zero. So let's go through each of those. I'm going to blitz them. You should spend more time than just this video, but maybe this will be a good start for you. Okay, so 4AB. So let's just take an example. Let's just say we have a box and we've got some particles in it. Okay, and we know that as those particles move around, they're going to hit the edge of the box, and that's going to cause pressure. And they cause even pressure around the surface of the box because they're moving randomly. We have this random molecular motion. If we add more particles, if we increase the temperature, if we decrease the size of the box, all those things are going to increase the number of collisions. Boom. If I add more particles, if I make them move faster, it's going to increase the number of collisions and the pressure is going to go up. The opposite would happen if I took away particles, right? If I just deleted these suckers, then I'm going to have the pressure go down. So it all depends on what's happening. So what you need to think about is, what are the particles doing? If you write an explanation, you better tell me what the particles are doing. Particles, particles, particles. Okay? I think in this one they also talk about diffusion. Remember, we sprayed the air freshener. That's air freshener. And it took a long time to spread throughout the room. Right? We had me with the air freshener, and then you guys are over here and over here. And because these gas particles are moving randomly, they take a long time to spread out. Right? Because if they just went straight, whoop, it'd be really easy. But they're not going straight. They're moving randomly. Sometimes they're going backwards, and they go this way. Okay, so that's the process of diffusion. Because of random molecular motion, takes a long time. Random molecular motion. Have I said that? Random molecular motion. Okay, oh my gosh, what happened? That was the wrong button. Sorry. There we go. That's the right button. The next one is 4C. I'm not going to review that right now, but I recommend you go to maybe this video, the one I made, or maybe this video, or maybe this video. Yeah, there's lots of resources out there if you're struggling with the combined gas law. STP, so that's 4D. Remember what STP is, right? So pressure can be 1 atm and a whole bunch of other things, right? Those equalities, what 1 atm is equivalent to, will be provided to you on your formula sheet, but you've got to be able to use them with conversions and whatnot. You also need to remember, not T1, that's the wrong thing. You also need to remember standard temperature is 0 Celsius. Is that absolute zero? No, it's not. Absolute zero is 0 Kelvin. This is 273 Kelvin. That is very far away from absolute zero. Now, is 0 Celsius cold? Yes, it's the freezing point of water. Is it absolutely cold? Absolute zero? No, it's not. Other thing that you need to remember with STP, standard temperature and pressure, is the molar volume of an ideal gas, which is 1 mole. Remember, a mole is a number of particles. We'll study that later in the year. Is equal to 22.4 liters. It doesn't matter what type of gas it is, as long as it's a gas. So it could be oxygen, neon, helium, lions, tigers. Wait, no, those aren't gases. Oh my. You can use this in conversions. So if you have 3 moles of gas and it's at STP, you can convert it. Unit you're coming from on the bottom, unit you're going to at the top, and then use that equality. So you multiply that, you get what, 67.2 liters. You get the idea. Okay. Last one was 4EF. This is about temperature scales. Remember, we have 2 temperature scales. Scale 1, scale 2. We have the Celsius temperature scale, which is more convenient for everyday life, although we don't use it. We should. And then Kelvin, which is more useful for relationships and proportionality and things like that. Okay, so at absolute 0, that's 0 Kelvin, that's negative 273 degrees Celsius. This is absolute 0. So at this temperature, there is no energy. Particles have no energy. They're not moving at all. And they have basically no collisions. They're basically there's no pressure as well. Okay. Next significant temperature is 0 Celsius, which is now 273 K. This is the freezing point of water. Freezing point of water. This is what Celsius is based on, is water. And the next one is 100 degrees Celsius. Boy, these are not accurate spacings, are they? Because this one should be a lot farther, which would be 373 Kelvin. And this is the boiling point, again, of water, of H2O. Notice the spacing's the same, 0 to 100, 273 to 373. These are both 100 apart. So to convert between Celsius and Kelvin, all you have to do is adjust for the 273 difference. The spacing is fine, so you don't need to multiply by anything like you would for Fahrenheit. Alright, I hope that was educational. I hope this was helpful. Have fun with your reviewing. Adopt a growth mindset. You're going to do great. I look forward to grading your awesome work. Bye-bye.